This question is from Class 12 RayOptics exercise 9.17 of the NCERT book. Here it's given an optical fiber which they have called it a light pipe. So here ray incident on this gets refracted along this, internally reflected like this, so it will proceed like this. That we know in an optical fiber. In the question, the refractive index of the core is given to be 1.68 and given it the name mu c, and the refractive index of the cladding, which is the outer covering, is given as 1.44. So we all know that the refractive index of the cladding should be less than the core. Only then total internal reflection occurs. The question is, we have to find the range of this angle I for which the ray will suffer total internal reflection inside the optical fiber. So for this, what you do is, this is angle I, let's call this angle R. This is the angle of incidence here, let's call it I dash. And the angle of refraction here, if I call it R dash, then at this point, if we use Snell's law, we get this refractive index mu c into sine of I dash is equal to refractive index of the cladding mu o into sine of R dash, where I have not drawn R dash. R dash is the angle of refraction in the cladding. Now, for total internal reflection to occur, first we have to find out the critical angle. We know for the critical angle, R dash is 90 degree, so this will be sine of 90 degree mu naught, and this is mu c into sine of I dash. So I want the critical angle, so let's call it C. So that means sine of C will be mu naught by mu c, because this will become 1. Mu naught is given to be 1.44, mu c is given to be 1.68. So we'll see that this critical angle C will come out to be 59 degrees. Okay, now see, since the critical angle is 59 degree, that means this angle of incidence here, that is I dash, must be at least 59 degree, or you can say I dash, its minimum value must be greater than 59 degree. Okay, now take this triangle. This is horizontal, this is vertical, so this is 90 degree. That means R plus R, I dash, this is equal to 90 degree from this triangle. This triangle is a right angle triangle. So that implies R is 90 minus I dash. Now, if the I dash is more than 59 degree, it has to be greater than 59 degree, then the maximum value of R, the maximum value of R will be 90 minus 59, that will come up to be 31 degree. So this R max can have the value 31 degree, so this R cannot be more than 31 degree. Okay? So if this maximum value of R is 31 degree, now we apply Snell's law here. So we have sine I divided by sine of R max equal to mu. This is the refractive index of core, so that is 1.68. Now when we have R max, here we have I max, that is when angle of refraction is maximum, so obviously angle of incident will be maximum. So I can write it sine of I max. Sine of R max is 31 degree, so sine of I max will be 1.68 into sine of R max is 31 degree. So when we calculate it, we'll see that the I max will come out to be 60 degree. That means the angle of incidence here can be 60 degree at the most. So the range of values that I can take, the angle of incidence I should be greater than 0 and should be less than 60 degree. So the angle of incidence must be between 0 and 60 degree. But in practice, since this will have a finite length, the minimum value will not be 0, because 0 will means, if angle of incidence 0 means it is incident like this, so it will go like that, so it will be some other value more than 0, which will depend on the ratio of the diameter and length of the girdle. But for the exam purpose, if we find out this is sufficient for us. Okay?